Alright, the next video on our list here will be we're in the binary categories again, so this is still binary naming, which means 2 again, but instead of going off to the molecular side, we're going to the ionic side. Again, so that first decision of binary means that there's only 2 atoms in the name or in the formula. We're coming over here. We earlier talked about molecular, which is the same word as covalent, which means non-metal to non-metal. Okay? But we're not doing non-metal to non-metal. We are going to go to ionic, which means we have a metal to a non-metal. Now, we are going to focus on this lecture on the metals with set charges. There are really primarily 2 rows of the periodic table that have set charges. Row 1, which is known as the alkali metals, in which every one of those is a +1. Row 2 of the periodic table, which is known as the alkaline earth, and those have set charges of +2. Every single member of those families has the same charge. They never change, they never vary, always the same. So because of that, we do a lot of assuming. We don't have to write things out like we will with other metals that don't have a set charge. So for example, NaCl will simply be written, and all of these are written, cation, anion, IDE. So I will write sodium, chlor, and I substitute in I. There's no Roman numerals, there's no prefixes, there's nothing there because I don't have to have that number that you'll find later when you look at the other video that is talking about multiple charges. Okay? Now to flip-flop this, what do we do when we need to write a formula from a name? Well, here's calcium oxide. What we need to do is we need to know that the 2 pieces are calcium and oxygen, but we need to know what their charges are. Well, the periodic table provides this information. Both of these elements exist in the columns that are set. Calcium is always a +2, always has been, always will be. Oxygen, for most purposes in general chemistry, is always a -2. Those 2 have charges that cancel each other or balance out. We're therefore able to know that it will take 1 atom of calcium and 1 atom of oxygen to make CaO. Not always is the case. Sodium oxide, great example. Sodium comes from a set charge of a +1, oxygen's a -2. Those 2 don't balance. I need more sodium than I do oxygen. Okay? I know it is going to be Na and it's going to be O. Now there are 2 ways to go about this. I know I'm going to need an extra atom, so I write it in here. I know that it's going to be Na2O. Another way that is traditionally done is this. If I know that the Na is a +1 and the O is a -2, I can cross the charges. Bringing this 2 down here, the 1 there, I get the same answer of Na2O. So crossing the charges is a method that is used, kind of a least common denominator is what we're looking for here to get these so that they cancel out and balance out.